Hi everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 23. And today we have another group episode which will be all about Git, one of my favourite topics to geek out on. Let's give both of our guests a proper introduction. So James World, whose name might ring a bell from episode 16, where he joined me to talk all about learning and self-development. And James is a solution architect and, so I'm going to take a deep breath here, Microsoft certified Azure Solutions Architect Expert. That's a bit of a tongue twister. And he's done a ton of talks, including at .NET Oxford, the user group I run, and we've also both co-founded another user group together, Azure Oxford. So welcome back to the show, James.
Thanks, Dan.
No worries. I'm glad I didn't put you off the first time.
I enjoyed it. It was good. Looking forward to this one.
Oh, it was good fun. And we're also joined by Jesse Liberty, who you may know from the Yet Another podcast. So he's a principal software developer and Microsoft MVP, and he's also recently authored a book on Git. So welcome to the show, Jesse. It must be strange being a guest rather than a host, I guess.
It is a little bit odd. Thank you for the welcome. I'm really glad to be on this side of the table. Looking forward to this. And, I should tell you that if I start to sound like I'm imitating you, I have this disorder where if I'm with anybody with an accent for more than 5 minutes, I begin to sound like them. So pay no attention to that.
You don't want to start sounding like me, that's for sure.
I was in England and Ireland for 2 weeks. And when I was leaving, I went into a shop and said, I'd like some scones and tea for takeaway. And she said something, I don't know what, I had luggage. She said, where are you going? And I said, back to the United States. She said, but you're from here. So that was a great compliment.
Yeah, I find even just like locally, if you move from one place to another. So I'm originally from Lancashire, which is a few hours up north. And when I moved down to Oxford, when you go into a chip shop up north, you can say chips and pudding and they'll know what you mean. So chips and steak and kidney pudding. Down here, I got completely blank looks, and that's a few hours away. So
it's amazing in the UK for such a small country how little the distance is between significant changes in regional accent and terminology.
Yeah, in the States you get a big difference in accent, but not so much terminology. Well, you get some, but we're a little bigger.
Yeah.
I think we're starting to pinch all your terminology because even my two kids, because they're watching a lot of American programs, then they're coming out with all sorts of definitely American terminology.
Oh, you have to turn that off.
Yeah, we've tried, but... Right, so before we dive into Git, I'm going to do this episode's listener mention, and this one goes to Laurent Kemp, who's, I believe he's from either France or Switzerland, so again, I could well have pronounced his name incorrectly there. I should put a French accent on there. But he says, fantastic episode of the Unhandled Exception podcast by Drakan, and I'm Drakan on Twitter, Martin Barrio and Kirill Skrygan, as guests talking about JetBrains Rider and JetBrains Code with me. I've wanted to have a deeper look at their reactive distributed communication framework for so long. So thank you for your tweet, Laurent, and he's referring to the last episode. So because this is a group episode and all three of us are very experienced in Git, and I think we've all taught Git in one form or another, I thought that this would make a really good roundtable discussion about what's good about Git, what's bad about Git, what people struggle with, and all that kind of thing. And obviously, well, I say obviously, not obviously for the listeners, but we've got quite an in-depth Google Docs with lots of ideas that we all put together. So I think there's lots of really interesting stuff to cover. But I think we should perhaps assume the listeners already know what source control is, because I think that's perhaps starting a little bit too basic. I think most listeners will have used some form of source control, if not Git itself. But I think a very good starting point might be what makes Git different to other, say, non-distributed source control systems. Does anyone fancy taking this one?
Well, you said the magic word.
Distributed.
You said other non-distributed. Exactly. I think there are two things in my mind that make Git different from other source control. One is that it is distributed, and that has many advantages, not least of which is if your repository crashes, it's possible to recreate it off of someone else's. And the other is speed, and we can talk about the speed advantage in Git, which is, I think, what finally made Git the winner, if you will, in the contest among source control. That and the fact that all the cool kids went there.
I do think the whole distributed nature is also one of the things that makes Git more complicated than other source control systems. I guess, like, for example, when I've been teaching people Git, from the very beginning, before we get onto explicit branches like feature branches, we can still get branch divergences between the same branch, the local and remote representation, like main versus origin/main. So developers really need to understand branches from the very beginning. And sadly, I don't think a lot of developers do.
Yeah, I think Git does treat branches in a very different way than a lot of its predecessors. And that's part of its power, the fact that branching is very easy to do and very fast. But it can also land you, I guess, in a lot of trouble, because if you start creating branches in a very disorganized fashion, particularly branches that you share, then you can end up in a bit of a mess. I came into programming in the Microsoft space, and the first source control system I started using was SourceSafe. It's kind of an ironic name, I guess. More Source Unsafe would probably have been a better name. I can definitely remember more than one occasion of it getting corrupted, and exactly as Jesse said, you only had one copy versus a distributed copy. That could land you in some real trouble. So yeah, Git makes branching much easier and much faster, but you need to have, I think, the right mental model about how Git works, and that's probably something it's worth spending a little bit of time on once we sort of got through the basics.
Out of interest, when you're teaching Git, how do you start? Because the first thing I tell people is just don't think about it as a list of commits and think about it as a graph, almost like a linked list. And I tend to draw out different graphs, like showing examples, and it is very much like a graph, where I think a lot of people that aren't used to like Git might just default to thinking like a list of check-ins or commits.
Yeah, I guess the key phrase, it sounds sort of really academic and highfalutin, but it's what you call a directed acyclic graph, or a DAG, which is a fancy term for a really simple idea. So every sort of node in your graph in Git is a commit, and every commit except your sort of first commit will have another commit as its parent, and that's sort of the arrows in your directed acyclic graph. And the acyclic part just means there are no loops. So as you follow all of the parents, you're going to end up back at the first commit. And commits are immutable. That's a really important part of it. Once you've made a commit, you don't ever change it or edit it. Any action that you do on Git will create a new commit with a new parent. And having that model in your head, I think, makes it so much easier to understand what the various commands are doing. But I absolutely with you. When I'm teaching Git, I have Post-its all over the desk with little graph diagrams on, where I'm sort of representing each command in terms of how it changed the graph of commits, or added to the graph of commits.
That's very interesting, because I take a very, very different approach. And we'll probably see that through much of this. I do not draw the DAG. In fact, I don't start by drawing at all. I start by talking about commits right away on one branch, so I don't even bring branching in. And then, actually, the next thing is to talk about the difference between the repository that's on your machine and the repository that is on potentially a central hub like GitHub, and what the difference is there. And then, after that's all good, and we talked about checking into that branch, that's when I bring in the second branch. So it's really, it's sort of upside down from the way you guys approach it.
Yeah, and I guess when I've been explaining it, I've usually come into it at a point where people have already used it a little bit and are able to sort of manage the very basic workflow, but then have perhaps started to get themselves into problems where they're trying to share code or upload code to a remote repository or work with other developers that are working on the same branch. I think that having that model in your head of the immutability of a commit is really important, because it helps you see, I think, that at its heart, Git is actually a very, very simple model that has a set of commands that make it really, really complicated to see that simple model. When you're pushing and pulling from a local repository and a remote repository, all you are really doing is exchanging commits that the other side doesn't have yet. If you create a commit or any number of commits, any number of branches and do a push, all you're really doing is sending those commits across. And when you're pulling stuff down, all you're doing is pulling the commits that you don't have yet. So you're sort of filling up your graph with the bits of the remote graph that you don't have. Nothing is being sort of edited, it's just being added to.
I wonder if it's worth, just for the listeners that haven't used Git, maybe taking a step back a bit and just explaining the fact that when you actually make local changes in Git, when you create this commit, that is local only.
Let's step back even further. The place where I begin is when I used to code and I was afraid of losing my code, I would make a complete copy of that directory. And then I do some more work and I make a complete copy of that directory. And the purpose of Git or any source control is to have that done for you with that safety in place. Now we can talk about Git, which is that copy. The first way to think about that copy is as a commit, is to say, I'm taking all of this code in the exact status I have and putting it into my repository. And then we can talk about the subtleties of that.
Yeah, I guess I'm also just thinking about the general workflow, just so that a new developer that's not used to Git, and for the time being, I'm ignoring staging just temporarily, but just to step back on James's point a bit, that when you do create a commit, like you've made a few pending changes in an existing project, you create a commit. I think that's an important concept to know, that that's local only.
Yes.
Until, and James used the term push and pull, until you push that to be shared with other people.
Yes, absolutely.
I think it's hard not to talk about that staging area, because a commit is a complete snapshot of the file system. Like at the point that you are, when you make it, you're going to make a copy of all of the changes that you want to parcel up and put in that commit. And so the process of adding something to a repository locally is that you're going to add a series of new files, edits to existing files, or maybe the deletion of existing files. And those commands, git add or git rm, are not actually changing the repository at that point. They're preparing your changes in a staging area. And then when you issue that git commit command, that's when you're making a new record, a new commit in the repository. And that commit is logically, it's a complete snapshot of the file system. And that's something that actually really distinguishes Git from a lot of other source control systems, where they would record their changes as deltas, as incremental changes to the file system. And that's one of the things that makes Git really fast, because when you're changing a branch and it's making your local file system reflect that new branch, it's able to very quickly work out what changes it has to make. Rather than sort of replaying or undoing a series of deltas, it can go directly to the commit that you're trying to check out onto the file system.
Yeah, I find that so useful. And I know we'll probably talk about GUIs and things later, but a lot of GUIs will let you effectively click to any commit in time and have a pane which is file tree view, and you can navigate the entire project as it was at that point in time. So as you say, it's just super powerful for just being able to jump to any point in time.
Yeah, and actually when I'm talking about that sort of Git at a deeper level, the place where I start is issuing what I think is the most fundamental command in Git, which is one that you'll never use. It's git hash object. And what that command does is you give it a file and it will create a hash, a SHA-1 hash of that file. And that's that sort of string of letters and numbers that is a unique identifier for that file. And the interesting thing to me is that it doesn't matter where you are in the world, what computer you're on, if you issue that command against a file with the same contents as somebody else, you get the same number. And that is then used to store a blob in Git's sort of database that represents, it has the contents of that file, it's named for the blob. And that's sort of the leaf of all of the information in that tree of what's in Git. So a set of blobs would be collected together to form a tree. And the tree contains the names of the files that you've got against each of your blobs and the hash of those blobs. And then it itself is then hashed. That list of blobs and their names is hashed to create a hash for the tree. And a tree can contain blobs and other trees. And then when you get to the root of the whole piece, the root of your working set, the commit itself points to a tree and is itself then hashed. and its parent is included in the creating of the commit hash. So everything is tied together. And this structure, this is a mathematical structure that has a name called a Merkle tree. It's actually the same structure that's used to create blockchains. And it's this model that gives Git its integrity. It's almost impossible to corrupt it because everything is pulled together and it's sort of this self-verifying structure. And the fact, for me, the fact that files and folders and commits, they're all just part of this same tree. That's the elegant simplicity at the core of Git, that it's just using this one graph to describe its entire structure.
And I would argue, just so we get into it right away, I would argue that you don't really need to know any of that to become quite effective with Git. That it's useful to know that if you're curious about how Git is maintaining its integrity. But you can go pretty far down the road with Git, including many advanced commands and getting yourself out of a lot of trouble without knowing anything about blobs, without knowing anything about hashing, and just treating Git as an interface between you and the repository without understanding what's happening in the repository. So I think we come at this from slightly different ways, which is great. I think that'll make for an interesting or else violent conversation.
It's good to have different opinions. And I think I will agree with you. You can get really far with Git without knowing those things. But I found it was kind of like the light sort of switched on for me when I got frustrated because occasionally I would get into problems where I would maybe try and do a rebase or a merge and end up with commits that I wasn't expecting. I would understand, well, what's going on here? And if by sort of getting that extra level of understanding, understanding the underlying model, suddenly it became much easier to resolve that confusion. Commands were then started to do the things that I expected them to do. So, I mean, I think you're right. I think understanding that is not where you would start. And I went there once I had started to run into occasional difficulties and just needed to understand what's going on. And it helped me resolve those problems.
Fair enough.
I think it's quite interesting because I'm kind of with Jesse in the point of I've had to resolve lots of rebasing, merge conflicts and things, and I don't feel I've had to understand it anywhere near that deeply. But one question I'm really interested in, it sounds like when you do know it this deeply, you can probably find lots of unorthodox, non-standard ways of using Git for other stuff as well. I'm quite interested if you've used your deep knowledge of Git to do anything that's not standard.
I think obviously it's an application that's been designed with source control in mind, but it kind of works for anything where you want to store versions of things and develop them in parallel. So I have used it in a software system that was for creating and storing contracts, legal contracts, where they're actually developed as part of the maritime industry. So they're quite complicated. They're evolved and developed over time. And people need to know very clearly when individual lines have changed and what hasn't changed. And it worked really well to use Git as a model for storing files in that system. So yeah, I think there are other applications, but yeah, 99.9% of what I use it for is source control.
So when you were doing that, were you using these, like the hash object command? So were you using that to, at a lower level, interact with Git?
No, that was really just part of the understanding. I think just the usual commands that you and I would use every day are perfectly fine for working with it.
I remember you did, I think it was .NET Oxford quite a few years ago, a talk on Git talking about all of this stuff. And it was fascinating because, as I say, like I use Git a lot and I feel like I understand rebasing and all this kind of thing very well. But when you go deeper, I probably don't know it very well. And I found your talk absolutely fascinating. So I'll definitely include a link to that in the show notes.
And it was interesting, actually. The other day I was having a conversation with a developer that was talking about rebase and saying, well, rebase moves a commit, right? And that's just not true. You can't move commits. You can copy them somewhere else if you're copying them to a remote. But locally, anytime you do a rebase that is doing anything interesting, you're actually creating a new commit and you're moving a branch to that new commit. And again, that's where I find that knowledge of the internal model makes that really obvious to me that that's what's happening.
Do you find that, because I completely understand what you're saying, that it's not actually moving the commit, but to get someone that's new to Git to kind of understand from a conceptual level, rather than implementation detail level, just what a rebase is doing. I find when I draw these diagrams, even though it's not moving a commit, I find actually showing the branch that's being rebased, or obviously it's replaying commits, but by drawing it like it's moving it, helps people understand it, even though they're maybe not understanding how it works under the hood correctly. They're understanding how to use it.
I think going to Jesse's point is that I wouldn't necessarily start with that complexity around the fact that it's not moving a commit, because for to get the basics down, you don't need to get to that level of difficulty. But the first time you hit that classic problem where you're working on a branch with somebody else and you're sharing it through a remote, and you do a rebase, and then they suddenly end up the next time they pull with a sort of duplicate set of commits, and they're wondering why that happened. That's where the diagram that shows the fact that you are creating a new commit and not moving a commit gets useful.
I would argue that if you did that, you did something wrong, which is to say you did a rebase on the server, on the shared code. And the way I avoid that problem is I only do my rebasing on my local repo and then push those changes. Because otherwise, you've effectively rewritten history out from under the person you're sharing that branch with. So, and that will cause enormous, and in fact, that can get you into a cycle of getting back the old code and then rebasing that, and around you go. What I do draw a distinction early on, as soon as I start talking about rebase, is that you merge into another branch, but you rebase onto the other branch. And then it's easier to talk about, well, why would you want to do that? And what does that look like? And how that becomes essentially a totem pole. And at that point, I would say, now you're not actually moving it, and you don't have to do anything. That Git is actually making copies and moving or setting them that new relationship. So I do think you can get there, but I don't usually start with the fact that it's a copy.
I guess like from teaching someone that's new to Git, there's like maybe a logical order to explain things. But I don't know about you both, but I've worked with a lot of developers who have used, and I'm going to put used in air quotes here, but they've used Git for years, but do literally blindly push and pull and don't understand things like rebasing and things. And I don't know, personally, I consider rebasing as being like a core Git fundamental. And I find that devs that tend to hate Git are perhaps the ones that haven't spent time to understand it. So like they get backed up into a corner when something slightly different happens. I think, Jesse, in your notes, you put that 90% of developers are using Git.
According to Stack Overflow, it's either, I can't remember the number, it's either 93 or 97. It's the vast majority of developers are using Git to some degree or other. And that may be, just to hedge that may be 90% of the people who use source control at all. But I would argue that you want to use source control even if you're working alone.
Yes, definitely, absolutely.
Yeah, I agree. Yeah. And I always do as well. First, every time I'm working locally, first thing is get in it, because it's so easy and so quick to create a repository, and having version history, even just to yourself, is very useful.
And it's so unpleasant to lose work. There's nothing I hate more, is what I'm trying to say, than redoing something I've already done. I don't mind taking the challenge of something new, but if I've done a certain amount of work and then lose it and then have to redo it. So I'm a big believer, and here's another place we may or may not agree. I'm a big believer in commit often. Commit, commit, commit. And then if you want a nice clean history, use interactive rebase, squash down all those commits, combine the message that will be displayed before you push it. How's that for simplistic?
I completely agree with commit often. For going for a nice clean history, I would say I generally don't squash down to a single commit necessarily. I'll tend to organize the information logically, because I'm trying to, with history, I'm trying to tell a story that's easy for people to understand. As developers, we exist to write code to solve business problems that bring value to businesses, and we create programs, and it's programs running in production that are important, but they have to be evolvable, they have to be maintainable. and understanding how they've evolved and maintained is an incredibly important way to make them easier to understand and to read. And actually, I think we probably don't leverage the power of Git as much as we could to help in understanding code bases that we are working on and maintaining. And sometimes that's because the history is a mess.
We're in 100% agreement. I didn't mean to imply that I squash it down to a single commit, but exactly as you say, to a series of commits that tell the story, squashing the interim, just safety commits.
Yeah. I think one of the things that you mentioned to me that was quite interesting was that phrase rewriting history, and whether or not that's a good thing or a bad thing. And obviously we're talking just now about rewriting history on your local machine, kind of before it's shared on the server.
Mm-hmm.
And I think that question of whether or not you rewrite history, I'm putting air quotes on, you can't see that, on the server, is something you should do or not, is a contentious point, because I actually think it's okay to do that as long as you do it in a controlled way. So the question of whether you should merge or rebase does come up a lot. And I think one thing I would always point out is that you have to merge eventually, right? Rebase doesn't integrate your code. So even if you're rebasing, you're still going to follow it up with a merge afterwards. And if you are, say, creating a branch to create a pull request, and you've got your changes on it, rebasing is actually doing two things. First of all, if you do it interactively, it's giving you that opportunity to create a nice clean history. But also, if you are rebasing a branch onto, say, master, you're incorporating all of the changes that have happened on master since you created your branch into that branch. And then obviously that enables you to test that the changes you've made work against the most recent changes that exist on the main line. And I would certainly advocate for frequently updating any branch that you are forced into making a longer lived branch than that. Any kind of longer branch, you need to be checking that does this change I'm making work against the context of other changes that may have been pulled into master since you created that branch.
Yes, I completely agree. If you're working on a branch for any length of time, you want to bring the master into your branch so as to minimize the number of conflicts that you may run into. If you don't do that, you can go on and go on and go on, and then you must do it at some point, and you can have a very long number of conflicts which are difficult to resolve. So I totally agree in terms of bringing the master into your branch. But at some point, you need to put your branch into the master. And that's where I would avoid rebasing. That's where I would use a merge at the point that I'm actually finished with my branch and I wanted to go back into the master.
Yeah, and I think if you have just sort of rebased before you do that, so before there are any other sort of changes on the main line, then you do have another choice, which I think is quite interesting, because when you merge a branch into master when you're done, if you have just rebased that branch and you're up to date, then by default, Git will do something called a fast forward merge, where it will see that the current position of master is now strictly in the history of your branch that you're trying to merge in. You walk through maybe you've made 3 commits, and the first commit you made, because you've just rebased, its parent is now where master is currently sat. So when you do your merge, Git's going to go, do you know what? I don't actually need to create a merge commit here. I can just update master to be pointing at the same commit as the branch, and I've integrated the changes. That's a fast forward merge, and it's different from a regular merge, because a regular merge is, by definition, it's a commit that has more than one parent. So if you haven't rebased, if you have changes in both branches, then a merge operation will create a new commit whose parents are the 2 branches that you're trying to merge. And actually, I like to have it so that Git will always create a merge commit, even if I've rebased and a fast forward merge was possible. The value of that is then in my history, I can see still, a nice sort of linear set of changes building up on the master branch, but you get that kind of little side sort of branch line effect that shows where work happened as a group on a branch. And I find that very useful. I find it very useful to see this block of work, this sequence of 3 commits was done as a single unit of work.
Yes, I agree.
It's almost like if your commits in your feature branch are telling a story, the branch coming out to show that history, it's almost like namespacing it so that the commits can be just about the feature, but you don't need to re-explain the feature in each commit. Where if you kind of fast forward merge that so that you had your 3 commits or whatever that's in the feature branch suddenly on the main branch, then you wouldn't know that they were part of the same feature unless the commit message was very descriptive. So I think, as you say, having that branch coming out and then back in again shows a really nice story and groups them together quite nicely.
Right. And we seem to have, and it's absolutely natural, a little bit of confusion or we're trying to hit 2 different audiences at the same time. Those who use Git quite a bit, in which case what we just said makes a lot of sense, and those who are relatively new to Git, in which case I do want to say that I highly advocate not doing your work and commits on the main branch, but creating feature branches for anything that you want to work on. And then when that is right, and you've brought in the master and you know that it's correct and you know that your work is correct and you know that your series of commits is correct, only then would I bring it back to the master. And in fact, I tend to work with 3 main lines. One is the line that is for pushing out to the world for production. The second is my development line. And so the development line only periodically goes to the production line. And then every single other thing is done on a feature branch. And I see you nodding, so I don't think there's a lot of disagreement.
Yeah, I agree. And I guess it also, you wonder whether a lot of Git users might do it differently depending on, going back to if you're a solo developer just working on your own versus having a team with lots of people, and then you can start introducing things like Git Flow or GitHub Flow and all these kinds of branching strategies. And whether, if you're developing something completely on your own, like a very small hobby project, would you still have these 3 lines of development?
But I have at least 2. I'd have at least my main line and my feature branches. I'm a big believer in feature branches. They make it much harder to hurt yourself.
That's always a good thing.
Yeah, and in fact, it's not uncommon to have your central repository set up so that you can't commit to the master branch. The only way that you can get code into master is by submitting a branch for a pull request to be merged into master to enforce that, which I think is a very sensible safety net.
I think Jess is right that we've kind of jumped forward and we are trying to hit 2 target audiences. And I wonder whether it's worth just stepping back a bit. So we've spoken about Git, we've spoken about PRs, pull requests. I think we've mentioned GitHub. And I guess for new people, there's probably a lot of confusion between even things like Git versus GitHub. And we've got pull requests, which aren't a Git thing. They're like a GitHub or Bitbucket or Azure DevOps thing. So can we step back a bit and just explain the difference between Git and things like GitHub or Azure DevOps, all this kind of thing?
Sure. One confusion that I see a lot is the difference between Git, GitHub, and GitHub Desktop. Git is what we've been talking about, the source control system. We talked about the fact that you can have a central repository. Probably by far the most popular one is GitHub. And GitHub is essentially a place to put your central repository. You can do more than that with GitHub, but that's a good way to think about it. GitHub Desktop is a GUI for working with Git that was created by the folks at GitHub. The advantage of it is it's extremely easy to use. The disadvantage is it's somewhat limited in what it can do. And there are a number of graphical user interfaces. The one that Visual Studio has is quite powerful, quite easy to use. And I've yet to run into, I'm trying to think if I've ever run into anything in the Visual Studio GUI that I can't do with the command line. I think I use the command line as much as I do more out of habit than the fact that VS can't do it. But James, what's your experience?
I'm a big fan of the command line. And I think that probably comes from the fact that I started to use GUIs when I first started to use Git, and then I'd sort of get into trouble. And it was then in researching and understanding a bit more how Git worked, I sort of realized, even using Visual Studio, which I think in the early days certainly didn't do as much as it does now, there was a whole bunch of things that you could do on the command line that you couldn't do so easily in the GUI tools. And I mean, I guess that's the command line is the interface that Git was originally created for Git. It's probably one of the more unforgiving user interfaces for a tool. It's had, I guess, quite a colorful history. So it has lots of sort of nasty edges. So, for example, it will refer to the same concept in Git by multiple different names. Variously, you can see that staging area we were talking about is referred to as the staging area, the index, the cache, and other names as well. So it can be quite confusing to wrap your head around some of the nuances of the commands. But once you have that model in mind, and you can get away with knowing only a small handful of commands, then it will let you do all of the basics, but it will also sort of unlock some advanced functionality that I think can be really powerful. So I'm thinking, for example, the ability to search through the code that you don't have checked out, like code on another branch using something like git grep. The ability to ask questions like, when was this particular function introduced into source control or last changed? So being able to use what's colloquially known as git pickaxe, the git log command with the /s switch, which will show you commits where the count of the number of terms you're searching for has changed, i.e. when a particular thing was introduced or removed, can be very powerful. Being able to understand when changes were made, who made the changes. You can answer some really interesting questions when you start to get into some of the analysis that you can do on Git. So which part of this enormous code base is changed most frequently? Who is the person that makes the most changes in a particular area of code? Because they're probably the person to go and ask questions about the stuff that you don't understand. In which particular commit was a bug introduced? And you might use a tool like git bisect, for example. So yeah, there's a lot of stuff that I think the command line certainly it makes it easier for me to use. And I guess the other thing is as well is that you're on somebody else's machine, or you're in a remote situation where you're on a terminal, and the command line's kind of always there, whereas your favorite GUI may not be.
Yeah, that's a compelling reason in itself. In the book, I show virtually everything that I talk about at the command line in Visual Studio and in GitHub Desktop, where GitHub Desktop can do it. So I totally agree with you that if you're going to go to something advanced or something where you may really not quite understand what it's doing, being at the command line sort of forces that issue. On the other hand, at least Visual Studio's GUI will do virtually everything I do with Git. So I'm sort of ambivalent about the two. And if I were teaching a new member of a team, I think at this point, because Visual Studio has evolved its commitment to Git so much, I think I'd probably arguably start them out there. But I'm not certain of that, actually.
Out of interest, I've never actually used Git in Visual Studio, but I've heard lots of people in the past say that it's a really bad experience. But I think I've been hearing more recently that they've been working hard, making lots of improvements on it. Have you found that it's drastically improved recently?
Night and day. Since Microsoft bought GitHub, they've made a huge investment in integrating that into Visual Studio. In fact, it's now a separate menu choice, and it's much more powerful than it was. It's much more intuitive than it was. They've really made huge strides, and I hear, I got to be careful here because of NDAs, but I hear that in the next version of Visual Studio 2022, that there's going to be even more enhancement to that.
Yeah, I think it's really interesting. I mean, I used to be at Microsoft around, or when Git was invented, actually. So before Git was a thing, I was at MS, and although we were selling the world SourceSafe at that point in time, I think probably one of the not so well known truths is that Microsoft actually had its own source control system internally for a lot of code bases. It's called Source Depot, that on the command line at least bore some similarities to Git in how you would use it, but it was never going to be something that was ever going to be made commercially available. It was too sort of rough and ready. But it always amused me that Microsoft didn't use its own product then. I think now that most of the Microsoft source code internally is been moved into Git, then that's been a real driving force behind improving the developer tools, because Microsoft are using the same system that everybody else is using now.
Yeah, so I guess with Git GUIs, I've always defaulted to, like, I use the command line as well, but I've defaulted to using GUIs that aren't part of an IDE, because I like alt-tabbing and having like a dedicated user interface. I'm a Windows user, so I don't know which ones of these are cross-platform, but there's like quite a few different GUIs you can choose from. Like SmartGit is the one I use, but that's a paid-for product. But there's things like SourceTree, Git extensions. You mentioned GitHub Desktop. TortoiseGit, which is if you use to SVN, then that's probably an easy transition. Git Tower and Fork, I think, are the main ones. But for years, I've been using SmartGit, which, as I say, it's a paid-for one, but it pretty much does everything I need.
Yeah. I guess even though I'm a big fan of the command line, one area where I do rely on a GUI tool is in comparison. So in diffing, I think the tooling is invaluable there. So I've been a long time fan of Beyond Compare for that purpose.
Do you like Beyond Compare? I use KDiff 3, but I'm always ambivalent about which of those two to use.
Yeah, that's something I've used for a very long time. I found Pro version of the license for, which allows you to do the three-way commit, is obviously invaluable if you're doing any significant merging. I think that there have been some other interesting tools in this space. There was one, I don't know if it's still a going thing. Semantic merge was quite interesting. That looked at trying to understand what code changes you were making. So it would call out, it was able to understand language and then say, oh, you're introducing this new class or changing this method or property on a class, which is quite an interesting take that could certainly make large PRs a lot easier pill to swallow.
I heard about that a few years ago, but I never ended up giving it a try. But it does sound fascinating, the diffs and merge tools that manage to actually understand the language and use some intelligence around that. I tend to use, so I mentioned use SmartGit by like talking about diffs. I tend to use like a combination of like SmartGit for just like doing the Git stuff, but then WinMerge, which is a free tool for just doing a two-way diff, but also Perforce, which is a completely different source control system. They've got a bunch of tools, and there's a tool called P4 Merge, which isn't just for Perforce, and it's free to download. I'll include it in the show notes, but I've tried a few different three-way merge tools, and this is absolutely incredible. And so I have my SmartGit. If I just want to do an external diff, it opens up WinMerge. If I'm doing like a merge conflict, then it opens up P4 Merge. And I find that's a really nice combination.
One of the interesting tricks I managed to pull off recently, which anyone can replicate, but has saved me a lot of time, is I'm developing quite often .NET destined for Linux containers, but working in Windows as my primary desktop. So I use WSL, Windows Subsystem for Linux, quite heavily. And if I'm working in a WSL image and I'm using Git within it, I still want to be able to use the diff tools that are installed on Windows. And all of these diff tools that you actually, you specify a Git setting in your config file that tells Git how to talk to your Git file, so that you'll have arguments to pass each side of the merge and so on. And you can actually invoke a Git tool hosted in Windows from a WSL image and pass in all the right paths. There's this nice trick with WSL. There's a hidden folder, $WSL, which will then allow you to go into any of your WSL runtimes and reach into their file system. So you can actually then execute a Git diff on your machine, and it will invoke the Windows tool and give it all the paths from your WSL container, so you can do the diff in Windows, which is pretty nice.
Yeah, it is insane, the bidirectional thing of WSL2. I think it was episode 7, we had Stuart Leeks on talking about WSL2. And it was like talking about all this kind of stuff. And it was he's written a book on it as well, which I read. And yeah, the number of tips and tricks and things like you've just described, it's insanely powerful.
It was actually his book that gave me the missing bit of information I needed to know to solve that problem.
I'll let him know. He'll be chuffed to hear that.
I told him, actually. I think I told him, yeah. Yeah, I used to work with Stuart. We were on the same team at Microsoft. So.
Oh, nice. I didn't know that. Well, I probably did at some point, but in our many conversations. Just going back to the Git GUIs, I'll include this in the show notes, but at the main Git website, I think it's git-scm.com, has a page with tens and tens and tens of GUIs, just a link to them all. So I'll include that in the show notes as well, because that's quite a useful reference.
We say other GUIs are available. I think it's the phrase you need, isn't it? Avoid getting into trouble with the advertisers.
Yeah, that's true. We need to be sponsored with some of these. Like I've mentioned SmartGit a few times. I need to.
Should we run through a couple of the commands that casual Git users may not be familiar with, such as bisect and blame and so forth? It might be worth taking a minute or two to talk about what they're for.
Yeah, definitely.
Okay, I'll start with bisect, which is a somewhat obscure command, or it's certainly not in the first set of commands you learn. But what it does is it helps you to find where a bug was introduced. And so you can use it manually by saying to it, here's a good commit, here's a bad commit, and it will narrow down to the first good commit. Is it the first good commit or the last bad commit that it, in any case, it'll identify where things went wrong. And if you hand it a bunch of unit tests, and we all have unit tests, then you can actually automate that process. So bisect is extremely useful when you realize there's a bug in your code, but you don't know when it was introduced.
Yeah.
Yeah, definitely. I find the problem is that now a lot of architecture is getting more and more, I'm going to say the word complicated, but trying to be microservice-y, where you've got lots of different things. I'm finding that nowadays it's becoming harder and harder to do that, because when you bisect down to an early commit, nothing compiles, everything's dependent on each other. So I used to use that a lot, but I must admit it's been a while since I've used it, but it's a really useful command though.
One of my commands that I find very useful but incredibly poorly named is blame. I think we need a new name for that.
I love this command. It's brilliant.
Essentially, all it does is it shows you, if you take a file that has some changes in it, it shows you who made those changes. And for every line, it tells you who made that change. And that can be extremely useful for finding the person and getting an explanation of what they were trying to do, or slapping them silly for what they've done.
So basically, who's written this bug? I'm going to find out. Git blame. Oh, it was me. No, it was me 2 years ago.
Almost always is. And we haven't even talked about the log, which is an extremely powerful command that is, in my mind, underused.
So are we talking about the log or the ref log?
No, just the log for now.
Just the normal log.
Yeah, so there's actually sort of almost the opposite of git blame that you can do with the log. One of the switches, I think it's --L, will tell you the history of a particular line or set of lines. So whereas blame will tell you who was the last person to change this line within a file, you might want to sort of look at it in the other dimension and say, how did this set of lines, maybe a function, evolve over time? And log will help you with that.
We can't talk about log without mentioning Hanselman's blog post on making your log display prettier and more useful using is it called Posh? Oh My Posh, I believe.
Oh, yeah. So this Oh My Posh, Oh My Zoosh, I don't know how you pronounce it. It's ZSH. There's a few different ones which do very similar. I think he's recently done a post about Oh My ZSH. And I think he's done a few, actually, but there's one like last week he published, I think. But yeah, he's got some nice-looking command lines.
Yeah, I think because Git had its origins, obviously, in Linux developers enjoyed richer prompts for many years, and yeah, PoshGit came along and redressed the balance on the PowerShell side to give you prompts that can inform, if you have changed files on your file system, what branch you're currently in. Yeah, incredibly useful. And then I call it Z shell. I don't know. I'm probably wrong. I'm probably being a Luddite. But certainly on Linux, I wouldn't have a prompt that didn't tell me what was going on in the Git repository I'm currently in. It's very useful.
I'm curious because I always never know how to pronounce it, so I'm going to Google ZSH pronounce. How do you pronounce? Oh, there's a Reddit.
Of course there is. Yeah.
So ZSH or Z shell. Z shell, of course. Oh, it's one of these ones where there's 5 billion answers, all of them different.
Yeah.
I'll start with the fact that you say Z and Americans say Z, and that's already going to be a source of confusion.
Yeah, see, I'm English and I say Z shell. So I've been in fact, this is a truism. I speak English, but I code in American because That's what all the manuals are written in.
That's fascinating.
So when the tangent completely, but the Azure CLI, do you say AZ or AZ? This is to James because I know what Jesse's going to say.
Mm-hmm.
Actually, I say as.
The third option.
Yeah.
Yeah, we'll have to have a show in which we exchange American versus Brit words and phrases and colloquialisms, and you can get yourself in quite a bit of trouble when you go from one to the other.
Yeah, well, as I said, I kind of train myself now to use American, certainly with code. It just happens naturally. Like if I'm writing a comment in my code and I mention the word color, I'm spelling it without the U.
Well, Americans are arrogant enough that we don't feel that we need to know any foreign languages or even other forms of English. We just assume you'll all succumb to ours.
We do the same here. We just say it louder.
So we mentioned about logs. Is it worth bringing up the ref log? Because I have found that this has saved me many, many, many times. I think, James, you mentioned earlier that Git is actually very safe. And I think one key point to make is that once you commit, it's very hard to lose that data. And when you're doing, I think a lot of people are scared by rebasing and things. It's, what if I mess things up and lose my data? And knowing about the ref log just kind of gets rid of a lot of that fear, I think. So to step back a bit, and the ref log is a command you can type, git ref log, and you basically get almost like a log of all the commands you've run. I don't like, you two can explain this a lot better than I can.
Yeah, so the way it works is this. So there is a magic branch almost in Git called head, and head is always the commit you're currently looking at. And what reflog does is it tracks the history of where head has been. So if you are, say you're issuing a rebase command, as we've described, rebase actually creates a new commit and will update the branch that you're currently on to that new commit. So when you issue the reflog command just after you've rebased, then what you're going to see in history is at the top of the tip, the new commit you've just created. And then before that, you're going to see the commit that you had prior to the rebase. Now that assumes that you're rebasing just a single commit. If you're rebasing a series of commits, then you'll see all of the commits that were traversed in that process, and it will tell you the commit at which you issued that original rebase command. And then you can take that information and then use the git reset command to basically move your branch back to where you were before you started the Git operation that got you into trouble. So that's your get out of jail free card, is that, or you can always go back to some earlier point in time using the reflog in that way.
You explained that so much better than I ever could, so I'm so glad you took over then. I was hoping you would. So I think continuing on with all these different commands, another one that's maybe more popular, but maybe some people don't know, is the stash command.
Yes, the classic scenario is you're on a feature branch. Let's call it feature A. And someone comes up to you and says, we found a bug in your code. You must fix it right now. Well, you've got code that you're working on that has not been committed that you don't really want to commit, but you do need to switch branches. So stash allows you to take that code and essentially stash it away, just as the name implies, and then go do the other work you want to do and then come back and pop that off the stash. And stash will also let you name, if you are going to have a number of things in the stash, it'll let you name them. And there are commands for manipulating the stash, but effectively it's a way to say, take my code where it is right now, hold it over here on the side while I do something else, and then bring it back. Did I get that right, James?
Yeah, and again, I think it's worth exploring it a little bit further. So once you have the basics down of how stash works, it's useful to know. Again, there's no magic here. It's all building on that simple model of Git. The way that stash is implemented, each entry in the stash list is just a branch. And the stash command knows how to invoke the right branch name to get to it. So I think the branch names are just called sort of @stash1, @stash2 with the @ symbol. And so they're just branches. But the stash command makes it really easy to put stuff into a stash branch and put it back out again. And it works like a stack, so you can keep on adding more and more stashes, and by default they'll pop off in the reverse order, which is nice and easy for basic usage. But if you need to reach in a little bit further, you can target a specific entry in your stash, or you could give it a custom name if you wanted to do that.
It's much cleaner than stashing things away in your feature branch. I mean, you could just do a quick commit of where you are, but then you sort of pollute your history.
Yeah, absolutely. And to go to yet sort of another level, and this is something I think that is much less well known, Git does actually support the ability to have more than one branch checked out at the same time. What you have in your local file system is called the work tree. And usually, and 99.9% of the time, you'll never need to know anything other than having a single work tree on your local machine. And I definitely advise you to stick with that. But maybe, just maybe, it might be useful to know that you can add more work trees onto your local file system. So you can use a work tree command and specify a different branch entirely and a different path, and you can have another copy of the repo checked out without having to go to the trouble of cloning another copy.
Every time I chat with James, like literally every conversation I have, I learn something new.
I hate that.
I like to know how stuff works. And it's mostly just reading the manual, right? But as Jesse said, the manual's really big.
Yeah, I also find, I must say, and we put alternatives to the official documentation. We can find one or two. I find the official documentation to be difficult unless you already know how something works and you're just looking syntactically. But it is so comprehensive as to become almost impenetrable.
Yeah, I really agree. And I think that's always going to be the challenge, right? And it's why many books exist on the same topics, because that manual does have to be comprehensive. It does have to cover how everything works. But you need a Jesse Liberty to come along and write something that's a bit more approachable for when you're starting out.
So speaking of learning things new, James, every time I talk to you, in our shared Google Docs, you did say one thing about, well, I think it was you, it might have been Jesse actually, because it was hard to tell who wrote what, but about why Git attributes is generally better than Git config. I don't think I've ever used Git attributes, so I think this is an opportunity for me to learn something new yet again. Should I be using Git attributes?
So I'm mentioning this specifically in reference to the problem of how Windows and other operating systems have different ways to represent the end of a line in a text file. So, famously, Windows will use a carriage return line feed combination, whereas Linux prefers to use and Mac just prefer to use a straight line feed. And if you don't do that, then you'll open up a file on Windows and you'll see sort of everything looking like it's on a single line, which can be very confusing, and similar problems can happen on other operating systems. So Git has a feature in setting config turned on by default, which will control this behavior. And usually you leave it set to auto and don't really think about it, and it will do the right thing depending on the operating system that you're running on. But the challenge can happen that you have to get that setting right. And if two things can happen, one can be that you might be checking out onto Windows, but actually developing on Linux. So if you're using something like WSL and or maybe you're copying files into a container, technologies like WSL and like Visual Studio Code's remote dev containers can expose this problem where you actually want to still use the Linux style of line feeds, even though you're running on Windows. So that's sort of one aspect of it. The other aspect is you may want to treat different files differently. And so the config setting is quite good for setting a global switch. But what Git attributes does, so this is a file that starts with the dots, it's a hidden file. It looks very similar to the way that git ignore works, in that you specify a path glob, and then you specify attributes for that path. And then certain Git commands will listen out for those attributes and apply them automatically when they're running those commands. And one particular set of attributes allows you to define how you should treat line feeds for things matching that path. So it's very common, for example, to have two build commands in an open source repo. One for if you're building on Windows, that would just sort of be a build.bat, for instance, and one if you're building on Linux, which would be a build.sh. And that's a really good example where you'd want to treat the line feeds differently in each case. So Git attributes is checked in to source control and is part of the repository, right? Whereas your Git config is specific to you. So if you want to make sure that you have consistency in how you're treating line endings for files, using Git attributes is a much better way to go because you'll automatically be sharing it with the rest of your team.
Out of interest, where you two have worked with lots of different developers that use Git at different levels, have you come across any constant mistakes that different developers use? Because I guess one of my pain points, and this is one I blogged about quite a few years ago, is one thing I see a lot of developers doing who blindly push and pull without understanding what's going on is I see a branch divergence of the same branch and then a merge commit of it going back in. And that's basically because they've got some local commits that they've not pushed. In the meantime, someone else has pushed some of their commits. Then the first developer has pulled and pushed, and the Git defaulted to create a merge commit. Because you've got the main branch or whatever branch you're in, and origin/main branch, which is the remote representation, you've already got this branch divergence because they are effectively two different branches. But then at that point, I would then rebase to get it back in line before I push my commits. But a lot of developers that just pull and push because Git defaults to merge instead, then that you'd end up in the history just the same branch going out and in, out and in. And if multiple developers are doing this, I see the history just looks horrible. So I guess that's my biggest pain point where developers don't really understand Git. Do you find any other little things where it's worth someone that's new to Git really making sure they understand from the get-go?
A couple of things I can think of. The first thing to say on that particular point, you're right that the default behavior for Git on pull is merge, but you can change that behavior. So you can issue a git config command to change the default to do a rebase instead, which can help alleviate that. But obviously, once the damage has been done, then you have to go fix it up. So that's not always quite so easy.
One way that confuses developers as well is if you change that default, because with a rebase, you can't do it when you've got pending changes. So with a merge, you can do it when you've got pending changes. So quite often developers would, if they change that default, get even more confused because suddenly Git won't do what they want it to do because they've got pending changes, but they can't pull or push.
Yeah, and I know Jesse wouldn't like it, but at this point, this is where I'm getting out the diagrams and drawing the graphs and explaining what's going on. And perhaps also pointing out that you can issue a Git fetch independently of a Git pull, and that will just pull in the new commits and allow you to look at what situation you've got yourself into, what has actually happened on that remote branch before you try and incorporate it into the tracking branch, the local branch.
That's a very good point, and that's one of the other things when I'm teaching a developer Git, as well as the graph thing, I say, don't pull, especially initially until you understand it. Don't use pull, because a pull is a fetch, then a merge or rebase. It's two commands together. And by developers just doing these commands separately and always doing a fetch so that they can see what's going to happen before they either rebase or merge, and then choosing whether it should be a rebase or merge themselves, I find that helps them understand it a lot better.
So I guess two pet hates I'll pick up on quickly is we've kind of touched on one of them already, and that's not sort of organizing your history to give a nice clean story in your pull request. But part of that is making sure that reviewing history is a part of the pull request review process that you employ. So, usually a developer doing a pull request review will only look at sort of the tip of the branch and not look at the history that's being submitted. If I see a pull request with 100 commits, then that's going to, I think something's wrong there somewhere. It's either too big of a change or it's not a very well organized and thought through change. So that's why I would definitely be encouraging an interactive rebase at least, or perhaps even splitting the work up into separate pull requests if it's actually representing distinct work. On a related note as well, if you have got commits, then having good commit messages to understand, explain the changes that are being made. So having a good standard about commit messages is really valuable. For a lot of work systems, then you'll often have a standard around mentioning something like a work item reference on a commit. And certainly, I always tick the box that makes sure that every commit is related to some work item, so you can track work through on development teams. But beyond that, there are some really nice standards available around writing commit messages in a structured way, which can help you not just understand the change that has been made, but also do things like allow you to automatically build release notes, at least for internal consumption, which you then might want to embellish for public sharing. there's quite a good site, conventionalcommits.org. It's a good one for the show notes, that proposes one standard for writing commit messages, which I think is quite useful.
Oh, nice. I've not heard about that one.
I have one question that I kind of wanted to ask Jesse that I feel I should. That's the question. So what led you to write a book on Git?
My experience was that most of the Git books that I saw were quite large and talked in detail about the internals of Git. And I thought that there were programmers who were using Git or needed to use Git, but didn't have the time or interest in a 600-page tome. And so the book that I ended up with is, I'm checking right now, is about 225 pages and covers, I believe, everything from a very, very short, quick introduction history all the way through some advanced commands such as bisect. And it does that by talking through what you do, why you do it, how you do it, but not necessarily what Git is doing under the covers. And one could argue that you need to know that, but I think you can get quite far on the information that I provide. So a little bit of log rolling here for my own book.
I'm glad you've written it. And I think to the point you made earlier, then before I told anybody about Git hash object, I would tell them to read your book first.
Oh, you're very kind. Keep telling them.
You need to kind of be at that level before I think you start thinking about the internals. I absolutely agree with you there. I think Git hash object and understanding that internal model is a sort of a next level that you want to aim for after you've got the basics down.
I agree. I hope. Let me just strike that. I agree.
I don't know if it's a good thing to mention, but I'm happy to mention it under recording that your book is available in O'Reilly. I have an O'Reilly subscription, so I did give a quick skim read of your book before we got together, so I sort of have an appreciation of what you've done. And it looked good. So
Thank you very much.
Also, one for the listeners, Jesse has very kindly said that we can give away a copy of his book. So what we'll do is, if anyone who's interested in joining the prize draw, if you tweet out about this podcast episode, including hashtag unhandledexception, and mention Jesse's book, then in a couple of weeks' time, we will pick a winner at random. Now, I'm quite jealous because I've not got an O'Reilly subscription like James has, so I'll definitely have to jump onto Packet and grab myself a copy.
Excellent. Make two. One you can mark up and one you can just keep. In fact, get another one for your mom.
Well, I'm definitely an ebook, a Kindle user. I've not had a paper book in years, so I best not draw on the Kindle because my other books wouldn't be happy. Yeah,
I'm also a Kindle. My wife works in an independent bookstore, but I'm a Kindle person, so I'm in great danger because they don't sell Kindle books in bookstores.
I remember years ago when I used to travel to conferences in the States fairly regularly, having to pay excess baggage fees quite routinely because I'd be buying books that had come out into print in the US but weren't available in the UK yet. So I'm very happy that Kindle is a thing, and other soft alternatives as well, like O'Reilly, obviously.
Yeah, one day another thing we'll have to have a discussion about is Harry Potter, but that's for another day.
So shall we do dev tips?
Okay, I actually have two dev tips, but unfortunately for me, James has already covered one, but I'll reinforce it, which is the importance of good and consistent messaging. When you're going through a history to try to find out what is happening, well-written and standardized messaging can make all the difference. And the second one for me is to have some kind of linting at the production level. I tend to use SonarQube for that, but there are a number of others. But having linting at the point where you're in DevOps to kick out anything that doesn't meet and SonarQube is extremely configurable. For example, one of the places I worked, we said that you can't increase the number of warnings. We had some legacy code. We had a certain number of warnings. That was fine, but you couldn't add anything that added to those warnings or would kick it out and refuse to put that into the build.
That's really cool. I've heard about SonarQube a lot, but I've never actually used it myself, so maybe this is the kick I need to have a play around. I do like that. So presumably, as your warnings decreased, that cap decreased as well. So you always had that cap that was lowering of number of warnings.
Exactly. And you can set, it's extremely configurable. You can set a whole lot of things and integrate it into we used Azure DevOps, and it integrates very well.
Very cool.
I got a couple of good ones here as well. And they're actually sort of, I guess, more related to GitHub than to Git directly. Have you heard of GitHub 1S?
I haven't. The only time I've heard about it is when you put it in the show notes, and I meant to Google it, but I didn't. So
Okay. So bring up any public GitHub repository, and when you do this, it's going to blow your mind. I mean, GitHub is a great tool, but I think sometimes actually searching through source code can be a little bit tricky to do without actually cloning the repo. So if you bring up any public GitHub repo, and then you go up to the URL in your taskbar, and you walk up to the end of the GitHub, and you put in 1S. So it's now github1s.com, and leave everything else the same.
So just the domain name.
Yeah.
1S. Okay. Oh. I've actually got another tip following that. Instead of doing that, press the period character instead of doing that.
How do you mean?
As in, literally, I'll go to any GitHub repository and press dot.
Okay, yeah. So this is going to open up the repository in a Visual Studio Code like environment, so you can explore the code.
Is that not the same thing, or? Oh no, that's different. That is different. I thought it was the same thing. Ah, interesting. When I tried it then, it looked similar from memory, but now I'm trying side by side.
So this is a project. It's not anything to do with GitHub, and I think it says that in bold across the bottom of the screen. And obviously it's something that you're going to be limited to public repositories on for that purpose, but it gives you a really nice way of browsing the source code quickly. And then on a related note, there's a similar tool, which is actually a Chrome extension. So it will work in both Chrome and in Edge, called Gitako, Gitako. And that will give you a file tree that you can browse that will add in to the GitHub when you're on a repository page. You get this little octopus tentacle, its logo is an octopus, and you get a little octopus tentacle creeping in from the side that you can click on to get a file tree to walk through.
Those are truly great.
That is really cool. So my dev tip is kind of a repeat from episode 5, where I was joined by Shahid Iqbal to chat about Kubernetes. And his dev tip was to create command line aliases for commands like kubectl, docker, docker compose, etc. His examples were K for kubectl, P for Pulumi, which he says he uses a lot. So my dev tip is to expand on this and include G for Git. So I have various aliases. So I use D for Docker, DC for Docker Compose, K for kubectl, DN for .NET, and of course G for Git. And the commands I use a lot, so it just saves me a lot of time and key presses. I also have a ton of Git-specific aliases too. So I think we are pretty much out of time, but thank you both so much for joining me on the podcast. It's been so good having you both on to geek out on one of my favourite topics.
Thanks, Dan.
Thank you. It's really been great. I'm looking forward to hearing it.
I must admit, I was a little nervous sort of coming in with a topic like this, which I think can be quite sort of visual in nature, that we would have enough to talk about. But I think there are some really big topics that we just didn't get to that we almost need another session to get through everything. So yeah, it's been really good fun.
I'm up for it, so you'll have to let me know.
I'm definitely up for that. Let's do it. And thank you everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying this podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter at Dracan, DRACAN, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And of course, we will include links to all the things we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.